Here's how a computer recognizes the same object in images, even if they rotate. We start by finding a distinctive point in the image, like the center of this puppy. Around that point, we extract a square patch and divide it into a 4x4 grid where each cell contains a grid of 16 pixels. In every pixel, we measure its gradient, indicating the direction and magnitude of the change in brightness from that particular pixel. The first step is calculating the total gradient representing the entire patch. To do this, we count the orientations, considering 36 possible angles, and weight their contribution by the individual gradient magnitude and their distance from the center. We obtain the patch's dominant absolute orientation, which will be useful later. The next step concentrates on the individual cells of the 4x4 grid. In a similar fashion, we count the gradient orientations within each block, always weighting them by their magnitude, but this time considering only 8 possible orientations. This creates a histogram that summarizes the local pattern of edges in that block, which can also be visualized as multiple vectors of varying lengths within that block. We repeat this process for all 16 blocks, obtaining the gradient histogram for each one. Flattening all these values gives us the SIFT descriptor of our object, represented as a 128-dimensional vector. Finally, we rotate the descriptor so it is aligned with the patch's dominant orientation. This step makes the descriptor rotation invariant, so even if our object is found rotated in the image, our computer is able to know what it is. And that's the SIFT descriptor.